Good afternoon, everybody, and welcome to our Aquarium Online Academy. My name is Alicia, and I am joined today with my friend Connolly, who is doing all the wonderful switching behind me to put up these images. Right now, we are all enjoying our wonderful blue cavern exhibit here at the Aquarium of the Pacific. Now, this program, we're going to be focusing on one of my favorite topics, which is fish. We have quite a few of those here at the aquarium. And we would love your participation. So if you're joining us live today on July 3rd at 2 p.m., you're welcome to text in those questions. You can see that number right below me here, the 562-286-1838. If you're joining us after our program has gone live, we'd love to still get your thoughts, your questions, your observations, explorers. All those are important to us, and you can use our email address at live@lbaop.org. Now, explorers, let's get into it. We're going to continue to practice our science skills today, which means that we're going to put on our lookers. We're going to make some good observations today. We're standing right next to this beautiful kelp forest habitat. And if you look closely, we might have some fishy friends joining us today. Now, we're going to be discussing what makes a fish, and how are they surviving in their different underwater homes or habitats. These special features on their bodies are called adaptations, and we're going to talk about that in just a little bit. But first, it's probably a good idea to decide what makes a fish a fish. So let's go ahead and we're going to put up, ooh, there it is. You see it in the back? That giant fish lurking in the background, that is our giant sea bass. That animal can get about 500 pounds and almost 6 feet long. That is, if I were to lay down, that is longer than me if I were to lay down in our studio here. That is a big fish. So let's go ahead and Connolly, if you could put up a picture of our giant sea bass. Whoa, look at this fish. Now, explorers, we're going to put our science brains on here and take a look. And my first question for you is, what are some things you notice? What do you think makes this a fish and not another type of animal, like a mammal like us, or a bird, or a reptile, or an amphibian? What is special maybe about this animal? Do we see anything on it? Now, I will tell you a little bit about this animal. I'll give you a few moments to text in if you do have any thoughts on this fish in particular, or this group of animals, fish, what makes it unique compared to other groups of animals. So I'm already noticing that this fish blends into its home. Did you notice that? Yeah, it has these really cool spots on it. Now, when you're able to hide in your home, we call that camouflage. You may have heard that before. It allows this big ocean animal to hide. Sometimes it hides from predators when it's younger with these spots, and sometimes it hides to sneak up on fish that it would like to eat. Okay, so explorers, you're probably, and it's okay, maybe you don't have a phone on you, you like to shout it out loud instead, that's okay. So besides those polka dots, you might have noticed that it has an eye, it has a mouth, it has these things on here to help it swim, its fins. Well, really there's just a few things that this animal needs to be a fish, okay? So really it is the fact that it has, and we can't see this, but we'll talk about it, it has a spine all the way down. You have one too, so if you reach around and you feel your back, we have a spine. Those are those little bumps in our back that makes us a vertebrate animal, so we have a spinal cord. So fish have that. It can be made of bones, or we'll talk about some other examples of fish that have a cartilage backbone. So there's that beautiful word. There's your science word today. Thank you, Connolly. So vertebrate, right? So if you're to say that, practice your science word, you can impress your friends that I am a vertebrate animal. And And our fish friends here also have that spine. Now, there are some big differences, though, between how we survive on land and how fish survive in the ocean. One of the biggest ways that they're able to survive is thinking about how they're able to breathe, right? So take a deep breath with me. Ready? Right? We're taking in oxygen, we're taking the air that has oxygen through our nose and our mouth, and we're filling up those big lungs that we have inside. And sometimes when we're running and playing, we might take faster breaths and we need more oxygen that circulates inside our bodies. Believe it or not, our fish friends here, they too need oxygen, but they get it from the water. Their oxygen bubbles are floating around, you can't even see them, and they use something that's hidden between this flap on their face, and they're called gills. Have you heard of gills before? Yeah, maybe you've heard of gills, right? Let's maybe peek at any fish. I'll have Miss Connolly put up a picture for us, and we'll just compare this gill opening here, this gill slit, and we'll compare it to another fish. Okay, explorers, can you point to that hidden gill opening? There it is. And fish often have this kind of plate in front of it. So if you were to inspect underneath, it's a little flap that opens. Look, you can make yourself into a fish. You can add, when you make your best fish face, you ready? You can add a fish lips, and you can add gills, like this. Perfect. Now you're getting closer to be a fish. They have that right here. And sometimes even fish will flare that when they're talking to each other. And they're like, hey, I want you to pay attention to me. They can actually lift this little flap. It's called an operculum. So that's the fancy name for this gill slit right here. So really, believe it or not, you just need those two things to be a fish, but it's pretty incredible. So they have a backbone or a spine, and they have those gills. And we're going to see when we investigate a few more animals that the gills can have a covering like this, or in some other fish they might even have 5 gill slits. So they're cousins, and maybe we'll put up one of their cousins that do have those so we can take a look. Sharks, ta-da! Can you find them here? It's kind of in the same place, right behind where the head of the fish is. They have those little gill slits. And most sharks, which are fish because they have the gills right here and they have their backbone, they have those 5 gill slits. Now, there are sharks that have more than just 5. They have 6 gilled sharks. We have frilled sharks that have a whole bunch, but mostly they have about 5. And so that makes them a little bit different. And we were talking about that spine, right? We were saying that they needed to have a spine. And most fish that we were just looking at and that we'll be exploring today have a spine just like us that's made of bone. And our friends here, the sharks, have a spine that's really light and flexible, and it's made out of cartilage. You might be thinking, that sounds kind of familiar. Have I heard the word cartilage before? We have cartilage on us too. We have it in the spaces between our bones, and we have it to support things like a nose and our ears. The fact that we can bend our ears to make like an ear sandwich means that it's light and flexible, and this structure that makes up the spine for sharks and rays also give them the ability to be light and flexible. So really, there are 2 big groups of fish. Those that have a spine made of cartilage, like our rays and sharks, and what we call our bony fish, which have that spine made out of bone. All right, so those are the 2 things you need, and you're probably thinking, wait, you didn't mention scales. Most fish also have scales as well, and that doesn't include all fish, though, and we'll talk about some exceptions for that. But many fish do have scales. Scales are mostly overlapping outside protection. Oh my goodness, what a wonderful photo that Connolly has put up for us. You can actually see the scales here. These are really large scales that have created a pattern on our sheephead wrasse here. And look, this is also a really wonderful example of the gill opening right here. And these scales provide protection. They often also have a nice mucus layer over the top of them. Yeah, it's kind of like snot, but it's a little bit more even, and they have this kind of constantly coming out of the pores on their body as protection. So if they had an injury, it would cover over that injury, kind of like a Band-Aid, which is really cool. Now, all of these features that we have been talking about help our animals survive. So again, we've been kind of thinking about what makes a fish a fish, and then what are some of these special things that they have that help them survive or live in their habitats. And this is called an adaptation. An adaptation. So our first science word today, if you remember, was vertebrate, and we're included in that category because we have a spine. And our second word, our science word today that I would like you to practice is adaptation. And that is anything that helps you, that's on your body, or even something that you do that allows you to survive. And so we have adaptations on our bodies. If you can think of something on your body that helps you survive, you can text it in. And we're going to continue to think about our fish friends here. So we have scales. Now those scales can be very different depending on the type of fish. So this fish has very large scales, and if we were to look under a microscope, I'm sure that they would be pretty impressive. They're kind of overlapping. They remind me kind of like roof shingles. So if you're driving through a neighborhood and you look at the different roofs, they kind of have this pattern on top, and that's to protect the roof of a house or a home or a building, and it's similar. Now, if we were to go back to one of our shark photos, they have very unique scales. If you've ever had a chance to visit the Aquarium of the Pacific, you can pet some of our sharks, and they have a very unique scale that has the same ingredients that make up teeth, which is pretty cool. In fact, the science name for their scales are dermal denticles. Dermal is skin, denticle, if that sounds familiar, that's like a dentist. And they have these skin teeth, so denticles for teeth. And if you were to pet one of our sharks one direction, it'd feel like sandpaper, kind of rough. And then if you were to pet them in the other direction, those tiny little skin teeth would push up against your finger. They'd have some resistance. And these provide protection. And scientists even think that for some of the sharks, these individual dermal denticles or skin teeth help them swim faster, which is pretty incredible. Look at that face. This is a little horn shark face. And although this is a very different fish than the giant sea bass we saw earlier, you might see some similarities. Look closely. What do you notice about the outside of this fish that might help it survive? We talked about a word that helps this some of our animals blend in. Were you thinking of camouflage? You're right. So this animal is using camouflage. They call it disruptive camouflaging. So basically, if another animal is searching around for food, they may not recognize a pattern like this compared to the rest of where it's living. And so it helps break it up. Same thing with another local shark that maybe we'll peek at, the leopard shark. I think we saw it earlier. Its patterns are a little different, but in the shadows of a kelp forest, these saddle markings on it really help break up the color. So it doesn't look like one animal, it looks like just a lot of different shapes, especially if you look at the habitat that it's living in, it kind of matches those same colors, right? So we've talked about scales, we've talked about a spine, we've talked about gills. Let's talk a little bit about fins. So fins are important for fish, but I'm going to show you an example of a fish in a little bit that doesn't quite have the same fins or scales, but most fish do have a pattern of fins. What do you these fins are used for? Yeah, you got it. They're used for swimming. So let's go ahead and let's go back to our blue cavern exhibit. And I want us to take a moment to see if you notice how the fish are using their fins to move through the water. Really specifically, scientists, what fins are pushing them through the water? Let's start there. Oh, we have some volunteer fish in the front showing us. So really looking at that push through the water. Which fins? Can you point? And you may even start to notice some differences in the fin shape and placement, where they're placed on the body. I'm going to grab an example fish here. Okay. Did you notice how they were pushing themselves through the water? So this tail fin, or caudal fin, is for many of these fish doing a lot of the work. Push, push, push. It's not the same for every fish. There are over 20,000 different types of fish out there. So this is some of the fish in here. They're using a lot of that push from the back, tail fin. And if we keep an eye, you might see some other fish in here using their other fins. We have some rays in here that are using their side fins instead. But for the fish that kind of look like this one, and we can see them in the back, you can see that push. So this, just like if you were to use your hands in the water and we go back and forth, you're going to get a little bit more push than if your hands were open or separate. So that pushes them through the water. Now, what about steering? If we look up here, we can kind of see. There you go. Do you see how they're using their side fins? They're pushing them out, they're tucking them in. Some of them are swimming from the sides that are like this, and some of them, my favorite, swim kind of like this. There's our wrasse in there. So there's a lot of differences, but typically we have fish using their side fins for steering. And then the top and bottom fins for many fish, not all, but many, are used for balancing. Maybe we'll see a couple fish in our next environment that you'll notice use their fins in a different way. Now that's the fun part about making observations or looking closely. We might learn a little bit more about the habitat depending on how we're making those observations. So, oh, there we go. Look, those are their side fins. This is giving the push to that ray. So a ray is one of those animals that fit into the cartilaginous fish category. So that would be the fish that have a whole skeleton made of cartilage that makes them light and flexible, the sharks and rays. And did you see it moving through the water? Maybe you can do that with me. They have their beautiful pectoral fins, and they're doing both balance and push. They have to be quite coordinated. And they look like they have wings, right? Their pectoral fins are really adding a lot of the push and steering. They do have a tail fin, and it's shaped very different. It kind of sticks out like a little tail, but it does help with balance as they move through the water. We've even seen some of those rays leap out of the water in nature, and a lot of that has to do with the force of their side fins or the pectoral fins and balance using that tail fin. Let's take a look. We talked a little bit about camouflaging in here, but do you notice any other patterns or colors? Do you see some of these stripes that we have in here? When we looked at our sheephead wrasse, we even saw some bright colors in this habitat that has mostly browns and grays, right? Let me show you a really bright colored fish that we have in this called the Garibaldi. This is our state marine fish. And this fish, unlike its habitat, really stands out. What do you notice about this fish? Again, you're welcome to text in. What do you notice? So while you're looking at maybe the fins or anything else on its body that stands out to you. We'll talk a little bit about color because that's why we brought it up. So color can be used in many different ways as an adaptation, a way to survive. So for this fish is actually pretty bossy. It likes to be bright, be noticed, and uses its color to almost communicate with other animals, to communicate with other Garibaldi fish, and to communicate with other fish in its habitat, saying, I have a space that's my space called a territory. I'm going to use my color to defend my space. And it's really trying to stand out. Sometimes when we go over to Catalina Island, which is only just over 20 miles from Long Beach here in our Southern California area, we can, on the docks, look down and see the Garibaldi. They really pop from this kind of blue, brown, and green habitat. So they're using their color a little bit differently. All right. I like to notice, and maybe you've already texted some of this in, or maybe you're just watching along with us, this heart-shaped tail. This is a little bit different than some of the other tail shapes that we saw. So this fish isn't really a fast fish, but it does make some quick movements to defend its territory. But it does like to stay pretty much in the same area. If we were looking at a fish that was trying to go really fast, it might have more of a moon-shaped tail to help it really cut through the water and have a little sharper lines on its tail fin. But this one is a little bit more rounded. It likes to stay kind of in the same place and hover all around one area. All right, I think it's time to show you that animal that I was thinking of. Miss Conley, can you bring up the eel? The eel is the exception to what we would think of for many fish. But this is a fish, right? It has a very different body shape. It has no scales on it, and it doesn't have fins. And it has a gill opening, which is right here to help it breathe, but not really a gill slit. So when we look at an animal like this, scientists, we have to kind of ask ourselves, I wonder why? How curious. And a lot of that has to do with the habitat that it lives in. So if you were to scuba dive where you would find a California moray eel, it would be in a very rocky habitat with lots of little cracks and grooves for it to hide in. So if you were to ever see a fish you don't know, you can start looking at the features of its body. Again, looking at color, you can look at the shape to give you clues. You can look to see where its mouth is placed. You can see even about its gills to give you clues to understand this animal. You can learn a lot without knowing the animal's name. Now, this eel looks like it's laughing at me. I really do like it. And if you ever wondered why the eel is constantly opening and closing its mouth, that's how it's breathing. So this eel has to be able to wiggle into these cracks and crevices, and it really gets close up to the rocks. If it were to have scales, those scales would rub off and it'd be pretty painful. So instead it has a pretty thick skin to be able to wedge itself for protection and also to have a safe space until it comes out to hunt at night. It has these pretty small eyes that don't see as well as some other fish. Instead, it uses its sense of smell. Now, a nose on a fish is called a nair. It's pretty close to our name, has this nair on it, and it allows it to navigate or find its prey or food in its habitat, which is pretty cool. Now, if it had big fins, again, that would get caught in its rocky habitat. So scientists kept asking, why? And then they observed the animal and were able to understand that the best way for this eel to survive in its habitat was to not really have the same fin shapes as most animals, to have different gill openings, to have a good sense of smell, and instead of having scales like other fish, it has this thick skin. Those are all really cool adaptations. So this animal is an example of one that maybe doesn't fit right into what we normally think of as a fish, but still is in that category because it has gills and a spine. Now, before we run out of time, I wanted to show you a tropical habitat and see if we can put some of those skills that we've been learning about fish observations to use. Now, go ahead and, whoa, look at those fish. This is a coral reef. So this is warm water compared to the cooler water we were just looking at. I want you to look and see if you notice how the fish are moving in here. Are they all moving the same with their fins? Are they moving different? Do they have the same shapes? I'm noticing that some of the fish in here have the same tail shape, and some of them are different, like this one that's very pointed. Some of them are using their side or pectoral fins in a way that's a little bit different than we've seen. So some of the fish in here are actually using their side or pectoral fins to push them through the water a little bit more. There is a current, meaning the water is moving through here, so it's a good example of seeing how these fish are moving through. What's really fun too is to look at their mouths. If you wanted a clue of what an animal eats, looking at its mouth can really help with that. So making observations to see, is the mouth really long? Is it small? Is it big? That giant sea bass had a really big mouth, and it just opens it up and sucks in its prey. Some of these fish here have very tiny mouths. This fish right here has bristles, has little tiny bristles on its mouth to help it scrape like a scrub brush algae. This fish here, do you notice its really long mouth? Maybe we can pull up an example of a tropical fish. Ooh, this is a great one. This is a butterfly fish. Now, I was going to talk about the mouth, but you may also notice that it has a pretty unique color pattern on it as well, right? So we'll talk about that in just a moment. Look at this mouth. This is not a fish that's going to be eating huge things. In fact, although it's pretty big on the picture behind me, it could fit about in the palm of your hand. It's pretty small, and it likes to eat even smaller things. It would really be excited to find a tiny little worm or a tiny little plankton or something really small between the cracks and crevices in a coral reef. And it uses that mouth to kind of peek in and grab it. So it's also right out in front, meaning that it's going to aim right in front of its body. Some fish have mouths that are faced up because its food is usually above, and some fish have their mouth all the way underneath them, like our shark here. This is an example of one of my favorite animals at the aquarium. This would just be a little baby, a little pup size, and they have mouths. Look at that little face. Look how cute it is. All the way underneath. So they could cruise along the sand. They would go down. They would check out the sand and look for snails, small crabs, anything small that they could find into the sand. So two very, very different mouths, but both are fish. All right, if you are watching live and you have any questions about the animals, we have about one more minute as we wrap it up here. But I just want to summarize some of the things that we talked about today, and also remind you that if you wanted to see those same exhibits that we showed you, the kelp forest habitat or the tropical reef habitat, you can find those on our website. So you can go ahead and practice those same observation skills. You can look and make observations of the fish and really think about how are those fish moving and how are they eating? How are they surviving using those colors and shapes? It's been very fun exploring with you today. Don't forget to reach out if you have questions, comments, answers, and we look forward to seeing you. We have another episode at 3 o'clock today. Thank you, everybody.